All right, hi everybody. We are going to do the second day or second lesson of classifying numbers. So yesterday you were working on classifying and you had this flow chart, and we stuck really with rational and irrational numbers. So we're going to be focusing on integers, whole numbers, and natural numbers. So yesterday we classified rational and irrational. We kind of stopped. But if you look on the rational side, beyond that, a number can also be more specifically classified as an integer. So you'll see 0 is right here in the middle, and then integers are, you could kind of think of them as your counting numbers and their opposites. I guess we don't count with 0, but numbers on a number line. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that goes on as far as you can count, and the opposites. Whole numbers, you can see, include our integers starting with 0, and they're positive. So a whole number is also an integer, it's also a rational number, and it's also a real number. It starts with 0, and then it's all of our positive counting numbers. And then natural numbers, the only thing that's different is that it does not include 0. What you'll notice is from anything beyond a rational number, there are no fractions and there are no decimals, with the exception of if a fraction or decimal simplifies to one of these numbers. So for example, 3 over 3 is equivalent to 1, so that would be a whole number. So if a number is written as a fraction and it can be simplified to one of these, then it would be. But if you had a fraction like 1/3, it's going to stay right up here in our rational numbers. So we're going to put a few examples of those numbers on our notes. Let's say we have a fraction, like I said, 1/3. That would go out here. It could also be a negative fraction, so I could have -2/3. But let's say we had a fraction like 6 over 3. 6 over 3 simplifies to 2, so that's going to go in here. So it's 2 in disguise. This number is 2, so it's going to go here in our whole numbers. Let's say we have a decimal, 3/10 would go out here. I could have -2/10. And then any repeating decimal is also going to be out here in a rational number. So a decimal can be here, or it can go on and on forever, but if it repeats, it's here. Remember, if it goes on and on forever, no repeats, then it's going to be irrational. Now our integers that are not whole numbers would just be our negative numbers, like -3, -10, 12, -12. And then our whole numbers would start with 0, and we could have 2, we could have 25, any number. But now when I'm reading this, what's important to know is that these whole numbers are also integers, and they're also rational, and they're also real. So you can start on the inside part and see what set its classifications it's all equal to. So let's look at 2. 2 would be in here, it would be a whole number, and 2 is an integer because the whole numbers are inside here, so I can circle 2. -3/4 would go out here in our rational number. That would not be an integer. -1 would be here, our negative whole numbers, so that would be an integer. Why don't you pause for a second, see if you can figure out where these two are going to go. All right, the square root of 9, we learned yesterday, is a perfect square, so that would simplify to 3, so that would be an integer. And 5 4/10, it has a decimal, so that would not be an integer. I forgot to put up here, our irrational numbers would be all of our non-perfect squares, so let's say the square root of 8, square root of 17, pi, our very popular irrational number. All right, and then down here, let's now practice actually writing our classifications. Oh, that got way bigger than I expected. Oh my. All right, don't know what's happening. Just wanted a text box. Reset. Okay, let's see if that'll work. Okay, so square root of 7. So I can ask myself, does this, can I put 7 cubes into a perfect square? I cannot. So since I cannot put that into a perfect square, this would be a real number. There we go. real, because every number here is real, and it would be irrational. So that's the only two classifications that one's going to have. All right, now we have the square root of, or not, sorry, 0.3 repeating. So pause here a second. Oh my. See. Oops. All right, so there's Mr. Heitkamp. Exit drawing. Here we go. 0.3 repeating is going to be real. It's going to be and rational. That's it. It's going to be -8 is going to be real, rational, and integers. All right, you know I'm making this in the back to school. There we go. Real, rational, and integer. Whole numbers do not include negative numbers, so we're not going to go farther than that. And then 0 is going to be real. It's rational. It is a integer. And it is also a whole number. All right, so remember classifications, they can have more than one. All right, thank you for listening.